Hi everyone, this is the final video of the semester. I'll be going through the practice exam for the final exam part 2. Alright, so getting into it, number 1 is for this relation. It says find the domain of the relation, find the range of the relation. Is it a function, why or why not? So the domain will be the set of all the first components. So 8, 6, 1, 9, 2, and 0. The range, maybe I'll do over here in red. That'll be the set of all the unique second components. So I see a 1, a 9, a 4, 0, 2. Even though 1 appeared twice, I'm not going to write it twice. I'm just going to write it once. So is this a relation? Yes. Is it a function? That's the question. So we need that every input corresponds to exactly one output. So in other words, no repeats in the input. So 8, 6, 1, 9, 2, 0. All the inputs are unique. So this is a function. And I'll just say because each domain member corresponds to exactly one range member. All right. So maybe going on to number 3. I'll post all the solutions next to the video. But going on to number 3, I'm going to graph actually both of these 3 and 4 in the same graph. I'll do this one in this color blue. So it's actually y equals negative 2x plus 3. Maybe I'll do this one in red. So to graph this, one way to do that, this is in slope-intercept form. So I can find the y-intercept, which is right here, right, the 3, and then I'll go down 2, so down 2 and over 1. So 1, 2, over 1, because of this negative 2 over 1 slope. And then just make a straight line with that. I'll try to find something I can make a straight line with. Okay, close enough. And there would be that graph of number 3. Number 4 here is y equals 1/2 x. So the y-intercept is essentially 0. And then from there, I would use the slope and go up 1 over 2. Up 1 over 2 as many times as you need. And then make that graph, and that line in red would roughly be the graph of this equation. Just hypothetically, so what if we were solving the system y equals negative 2x plus 3 and y equals 1/2 x. So the solution to that system would be whatever intersection we see right here. And you could solve that by like substitution, for example. So you could plug this thing in for y right there. So you can say 1/2 x. When does that equal negative 2x plus 3? So maybe I'll add over 2 x. So 1/2 x plus 2x would be 5/2. X equals 3. And then divide by 5/2 maybe, or multiply by 2/5, if you want to think of it that way. So we get 6/5. So X equals 6/5. And then the Y of this intersection point would be 1/2 of 6/5, right? As soon as I know X, I can take 1/2 of that. So Y would equal 1/2 of 6/5. 2 goes into 6 3 times, 3/5, this would be 3/5. So in other words, that intersection point, and this is a hypothetical, this is just a what if scenario, like what if we were solving that system? We would find X is this 6/5 and Y is this 3/5, which is reasonable, right, with that location. Moving on, I'm going to this second page, but this is number 2. So this is just the second page, but I'm going down here to number 2. So it says solve each equation. So zero product property, right? So what I'm going to do here is set x minus 5 equal to 0, or 4x minus 1 equal to 0, and then solve each for x. So x equals 5. Here I would still have 4x equals 1, and then divide by 4. So I'd have solutions as x equals 5 and x equals 1/4. For part 2, I would want to first subtract 1 over here. So we can write x squared minus x minus 20 equals 0. And then maybe some fast factoring. I can write x minus 5, x plus 4. So in other words, x minus 5 needs to be 0, or x plus 4 needs to be 0. So in other words, I get a 5 and a -4 for this one. All right, going to page 3. I'm actually skipping everything on page 3. Let's go on to number 3. This is on page 4. All right, so it says solve each equation. Please assume that all inputs result in radicands that are greater or equal to 0. Basically, you don't have to worry about absolute value, is what that statement essentially means. So what we want to do is isolate any occurrence of a root and then square, or use the appropriate power at least, to get rid of that root so that we can then solve the resulting equation. So I'm going to subtract 5. So x minus 5 equals the square root of x plus 7. And then square both sides. So we'll have x minus 5, I'll still square that, and then x plus 7 is the only thing that's left on the right. These essentially cancel. And then foiling here, x squared minus 10x, just some quick foiling. So we want to gather all the terms on one side, get a 0. Maybe this thing factors. So subtract x subtract 7. So x squared minus 11x plus 18 equals 0. We're looking for numbers that multiply to 18 and add up to negative 11 if possible. So x minus 9 and x minus 2 would be good numbers that do that. So it must be that x minus 9 equals 0 or x minus 2 equals 0. So add 9, add 2, add 2. So x equals 9, x equals 2. But you do need to check these. There's a potential for extraneous solutions when you use even powers to solve on both sides. So there's kind of a little red flag moment here. So we do need to check. So if I just kind of conceptually check, 9 equals the square root of 9 plus 7. This is the square root of 16, which is 4. So 9 equals 4 plus 5, which is true. So 9 works. 2 equals the square root of 2 plus 7. This would be the square root of 9, which is 3. So 2 placed here leads to a 9. Square root of 9 is 3. 3 plus 5 does not equal 2. So I believe just the 9 works. All right, so what about this one? Here we have 2 roots. So you want to isolate one of the roots, like we have on the left. And then you want to square the entirety of the other side. So we'll get a 2x minus 5 equals, and then what I'm going to do is FOIL this out. It'll be a 1 plus 2 root x minus 3 plus x minus 3. And what I now want to do is isolate this root and do the same thing as square both sides. So I will subtract x from both sides, and then this is a negative 2, right? 1 minus 3, that's negative 2, so I'll add 2, and that will destroy both of those numbers, if that makes sense. Kind of weird, but that is legit. So x minus 3 equals 2 root x minus 3. And then square both sides again, actually. Oop. So squaring on the left, we have x squared minus 6x plus 9 equals 4 times x minus 3. Distribute. And bring all the terms to one side. So x squared minus 10x plus 21 equals 0. So if it factored, we would be looking for numbers that multiply to 21 and add up to negative 10. So negative 3 and negative 7 do that. So I can write x minus 3, x minus 7 equals 0. 0 product property. So we're getting potential solutions as x equals 3 and x equals 7. But again, there's a couple red flag moments. Right, here's one. And then we used one way up here too originally. So we do need to check this. So just to do a quick check, if you have a 3 in here, you get a 6, you get 1 equals, right? I wrote a 1 because 2 times 3 is 6, 6 minus 5 is 1, square root of 1 is 1. And then if you plug the 3 in over here, you also get a 1, right? 3 minus 3 is 0, square root of 0 is 0, 1 plus 0 is 1. So you get a good answer on the 3. And to check the other one, 7. So with 7 we get 14, right? 2 times 7 is 14. 14 minus 5 is 9. Square root of 9 is 3. On the right, plugging in a 7. 7 minus 3 is 4. Square root of 4 is 2. 2 plus 1 is 3. So they both work actually in this case. All right, continuing. All right, this is the last page here. So it says, number 4, the velocity of water flow, V of P in feet per second from a nozzle is given by V of P equals 12.1 times the square root of P, where P is the nozzle pressure in pounds per square inch, PSI. Find the nozzle pressure if the velocity of the water flow is 100 feet per second, round to 1 decimal place. Okay, so here we're asked to find the nozzle pressure. The nozzle pressure is P. So we need to solve for P, given that the velocity is 100. So we have 100 equals 12.1 times the square root of P. So what I'll choose to do is divide by 12.1. So that will give 100 divided by 12.1 equals the square root of P. And then I will square both sides. So 100 over 12.1 all squared would equal P exactly, but then we're just asked to round this to 1 decimal place. So parentheses, fraction, 100 over 12.1, and then we need to square. So we would have about 68.3, and this would be PSI. Part B says, for an engine with a displacement of 2.8 liters, the function given by d of n equals 3.2 times the quantity 2.8 n raised to the 1/3 power can be used to determine the diameter size of the carburetor's opening in millimeters. Here n is the number of revolutions per minute, RPMs, at which the engine achieves peak performance. If the diameter of a carburetor's opening is 81 millimeters, so they're giving us what? D. Right? So they're giving us 81 is going to go for D. For what number of RPMs, N, will the engine produce peak power round to 1 decimal place? So we'll have 81 equals 3.2 times 2.8 n raised to the 1/3. So I'm going to isolate this and then raise this to the 3rd power. So divide by 3.2. So I have 81 over 3.2 equals 2.8 n to the 1/3. So I will raise everything to the third power to get rid of that 1/3 power. So we have 81 over 3.2 cubed equals 2.8n. And then I still need to divide by 2.8. So I would have n equals exactly 81 over 3.2 all cubed over 2.8, but we're going to round that to 1 decimal. So I'm plugging this in here. So fraction, parentheses, another fraction, 81, 3.2, parentheses. Actually, I need to cube that. Cube, and then all over 2.8. And this is about equal to the number of RPMs you would see at that diameter. So n is about 5,792, and then to 1 decimal place we'd have 0.2. This would be RPM. All right, one more. Here's number 5. It says, please write any imaginary numbers in the form of a plus bi. So a couple things we're going to use here is the fact that the square root of -1 is this imaginary unit, which leads to the fact that -1 would be I squared. So for part I, no pun intended, so we'd have to distribute this negative first. So we'd have 4 minus I can just get rid of those parentheses, and minus I minus 2I. The i's are kind of acting like terms. So I'm supposed to write the real part first. So -4 minus 3I would be this first one. J, I have -5I times 2I. This would be the same as -10I squared, but I squared is the same as -1. So this would be the same as +10. For K, I need to FOIL here. So I'll do the first, that'll be +15. The outside will be 9I, the inside will be 10I, so I'll just write 19I. And then the last will be 6I squared. And then simplifying, I can write I squared as -1. So 15 plus 19I plus 6 times -1. So in other words, in simplified form here, we have -6 plus 15. That would be 9. So in this form that they want, I'd have 9 plus 19I. Part L. So we first need to simplify I out of these roots. So the square root of -100 would be the same as the square root of -1 times 100. And then we'd have the square root of -1 times 9. For similar reasons, we would get I times 10 times I times 3, right? Because of these square roots taking place. So that would be 30I squared. But again, I squared is -1. So I'd have 30 times -1, in other words, -30. For part M, I have I to the 12th. So I to the 12th would be the same as I squared to the 6th, just by power rules. I squared would be the same as -1, so -1 to the 6th. -1 to the 6th would just be +1. All right, good luck to you all. Bye-bye.